do today? Most of you have some idea how to model motion using a function. And the function that we're going to look at is a body falling over time. This is going to be height. This is going to be time in seconds. It's going to be the height in feet. And the model that I'd like you to graph on this is 1 second, 2 seconds, 3 seconds, and so on. There you go. We're going to model f of x is equal to negative 16x squared plus 100. What I'd like you to do is substitute in those points and model that. Graph that.
I know that to be true, man. I know that to be true. You get ready yesterday, too. I want to do it. Yeah. Yeah. Yeah, you might want to do something. But if I can do it, you're going to say, I want to do it.
What's the time? Well, you guys are done already. That was fast. Good. What's this time? What time does this represent right here? 0. 0. And what is it at 0 seconds from now? You were supposed to already have done this. Guys, look, you can copy what I do. Second graders can copy what I do. Okay? You need to understand it. To understand it, you need to do, when I ask you to do something, please try it. Because when you get to the benchmark test, I'm not going to guide you through it. You got to do it yourself. When you get to the college entrance exam, that's going to decide whether you get stuck in remedial math for a couple of years or not. You have to do it yourself. Make sure that you do what I tell you to do. I know you guys can substitute 0, 1, 2, and 3 into this function and get values out of it. I know you didn't do it yet. Some of you decided that you were going to talk first. Okay. Upcoming weekend, I'm sure. Wonderful things happening. But let's focus on the math today. What happens at 0? 100. That's where we start. This is the model of a falling body. Mathematically, it increases at 16 feet per second squared, which is the acceleration due to gravity in feet per second squared. What happens at 1 second? Substitute 1 in there, we get 2 plus 100.
Oh, 100, no, 81.
184. Generally, objects fall down. 184. 0, 100. 2 seconds. Now what happens? Substitute, simplify. 2, 36. 36 feet. We call the slope the rate of change, but this thing doesn't have a constant slope. The slope is changing over time. As it falls, at first it falls slowly over the first second, but then it starts falling faster and faster and faster and faster and faster because gravity affects it in an increasing way. It keeps going faster and faster as it goes down. What is the slope between the first 2 points? is the slope of this red line? Find it.
Automatic out. It's like automatic.
The slope of the red line, m, is equal to y2, 84 minus y1, 100 over 1 minus 0, which is negative 16 over 1. Negative 16 what? Feet over 1 second. This is the average between those 2 points. This is the average velocity. Because in 1 second, how far did it fall altogether? 16. That means that it was averaging 16 feet per second. It started out exactly at 0 and ended up much faster, didn't it?
Yep.
That make sense?
Yes.
But it ended up averaging over this period of time 16 feet per second downward. Find the slope between the next 2 points. The slope in green. Do that one. Okay, here. This is y2 minus y1 over 2 minus 1, which is negative what? 48 over 1. Negative 48 what? Feet per second. It's sped up. It falls much faster during the second, didn't it? It fell 48 feet, fell 3 times as far. And in the next second, it's going to fall much farther. It's going to fall 5 times as far. In the next second, it's going to fall 7 times as far, and so on. It's going to continually increase in speed. What we're interested in today is what we call instantaneous velocity. This is going to be the slope, not at 2 points, through 2 points like these, but I want to find out what's the tangent line slope. In other words, what happens at an individual point right here, like this. Maybe I want to know exactly at 1/2 second, how fast is it moving? Anybody follow what I mean by that? Okay. There's a problem though. Let's go ahead and imagine for a second that I want to find out what happens at 0.5 seconds. First of all, I would have to find out how high it is, wouldn't I? Okay, let's find out what happens at 0.5. It's right in the middle there. Substitute in, how high is it at 0.5 seconds?
Working on it.
96, yeah. Let's load it. 96 feet. Everybody clear? We know where it is, but we don't know how fast it's moving. We have a problem. To find the slope, don't you need 2 points? You have to have 2 points to find the slope. What I'm interested in finding is the speed, which is the slope. Does everybody understand what I mean by the speed?
Yes.
That's the velocity at a given point. In this case, I want to find out what happens at 0.5. I want to find out how fast is this thing moving right here. So what I need to do is find the slope through 1 point. Well, that can't be done. Fortunately for us, Newton was a very smart man, and when he was 17 years old, he figured out a way to do it.